Hi everyone. This is a little interlude. My name is Linda Vilkas. I'm a children's book author. I'm an illustrator. I'm a programmer, and I'm a business school dropout. So what am I doing to a room full of engineers and scientists? Well, hopefully I'll be able to offer you in the next 10 minutes or so a vision of what the future of technology education should look like for the next 100 years. And I think it's very, very exciting to be here in Sweden today, because one of my personal role models obviously comes from Sweden, and that is Astrid Lindgren, who gave the world with Pippi Longstockings a role model that lasts for generations. But Astrid wasn't only a children's book author, she was very active in politics also, and the Swedes in the room might remember well the Pomperipossa Monismani debate article Astrid wrote to the big paper in Sweden, and she famously said that politics is too important to be left for politicians. And I think the year 2019 version of that sentiment is that technology is too important to be left for technologists. So we need a radically more diverse group of people to get excited about technology, computer science, coding, machine learning, and artificial intelligence. And that's what my job is about. So I write and illustrate picture books to children between the age of 6 to 9 about the fundamental ideas of computer science, trying to imagine how we could explain in a whimsical and colorful and exciting ways some of the biggest foundational ideas humankind has ever created. And I think there is this beautiful momentum around computer science happening around right now, where both the society, the educational sector, and the industry are recognizing how much we need these skills. But I do think that we're fundamentally doing it for the wrong reasons. Because no one should become a computer scientist because of the GDP of a country. No one should get excited about coding because the Prime Minister says so. And I think one of the misconceptions we have around computer science is this famous saying, or illustrates well the misconception, that often is attributed to the computer scientist Edgar Dijkstra, who said that computer science has as much to do with computers as astronomy has to do with telescopes. So what I try to do is explore these foundational ideas, ideas of abstraction, ideas of searching, efficiency, and do it with the 6-year-olds. And sometimes when we think about the field of computer science, it's easy to think about people who just sit in front of the computer, often in hoodies, and don't talk to other people and only work with the computer. And I think that is the first thing we need to start changing. And it's an easy mistake to make, because when we think about a biologist, we think about someone who studies the biological world. And when we think about a physicist, we think about someone who studies the laws of the physical world. So when we think about a computer scientist, it's easy to think that it's the person who studies the computer. But that couldn't be further away from the truth. Because nowadays the computer scientist is the person who uses the computer to study the big problems in the world, those of nutrition, energy, education, health, the wicked problems we've been hearing today a lot about. And that means I think we need a new name for the field of computer science, a whole new way of describing what this discipline is all about. So, again, how do you teach computer science for 6-year-olds? We do it by borrowing a lot from Maria Montessori, doing it in an unplugged manner without actually any screen time, because the next generation already, their metaphors for a computer will be totally different than the ones we use today. When I go to a classroom, roughly 70% of the kids already very comfortably say that they are having conversations with computers. So the anecdotes and metaphors we use to describe a computer, those of a screen, those of a mouse, a keyboard, are not going to be adequate for the next generation. And it's funny that when we think about the future of computers, we actually need to go almost 70 years back in time. And we need to go to the year 1945 when John von Neumann was coming up with the von Neumann architecture for a computer. And even though today computers fit into our pockets, they are everywhere in our daily lives, be they the toothbrushes or teddy bears we use. Back in the days, computers were bigger than this room, but the basic operating principle is still the same. Computers are devices that take input data, they process that data, and out comes the modified data. And that's the way I also teach to children. We often build a little cardboard box, and the kids scroll in, they are the input data. There's a little piece of program that tells them that you come out crawling or jumping on one leg or singing a song, and they become the output data. The kids get to explore the bossy CPU and the helpful RAM and ROM that helps remember stuff. They learn to spot algorithms in the wild. They make a scavenger hunt around the city and learn how the internet works by trying to spot the physical remains of the internet. And through these kinds of activities, I hope that the very abstract ideas of computer science will be made tangible and real for us. One idea that the previous panel talked about were the metaphors and ontology of how we speak about computers. And a few months ago I read this study from Oxford University where the researchers, they had shown kids two sets of pictures. In one set of the pictures there were pictures of natural objects and items like plants and woods and animals. And the other set of pictures included pictures of Pokemon. And by far, the children were far better at recognizing Pokemon. They were much better and had a larger vocabulary to describe Pikachu than the birch tree. They recognized Bulbasaur better than the badger. And the researchers were obviously worried because what happens to our agency? What happens to our ability to understand the world unless we have vocabulary to describe it? And I'm worried about this too. I'm worried how we lack the ability to describe our natural world. But I'm also worried about our lack of ability to describe the technological world. Because you see, we have so many of these suitcase words. These words that we throw from one person to another. Words like the Bitcoin, blockchain, algorithm, machine learning. And we never unpack those words, those suitcase words. And that's largely the fault of the media. But I think we as an industry of engineers, we need to look to ourselves too. A few months ago I had a little boy who came to me and asked, Linda, is internet a place? And I said, oh, this is an easy one. No, 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 internet is not a place. Internet is this interconnected network of servers. You can think of it as the information superhighway. It's like the cyber village. You go surfing online. And then I realized I sound like a kid of the 1990s. This child has never pressed the disconnect button. The internet for him is something that is invisible everywhere around him. And I need to update my metaphors. I need to come up with a different way of explaining what these technologies are. So should I talk about how the internet is the fiber optic cables that go from the bottom of the sea all the way to the space, or the server farms that host all of this data we create? Or should I talk about the software side of the internet, how that data travels around the world 8 times in a second? Or should I talk about the cat videos, the memes, the explosion of creativity that happens when the 6 billion of us can finally have a discussion with one another? And I think this is the challenge with teaching technology. It's not only the hardware, it's not only the software, and it's not only the societal impact technology is having. It's all these 3 things happening at the same time. And we need to invent new ways of teaching and cross disciplines and cross borders while doing so. And we need to accrue our own experiences and new metaphors of explaining these things. Oftentimes I get parents who say that my kid is only sitting in front of the computer, playing these horrible games or watching YouTube. And I think the challenge is that parents don't have foundational intellectual experiences with computers. They've never seen how a computer can be a tool of self-expression or problem solving. For them, it's easy to teach the children to make cinnamon rolls, or it's easy for them to coach the children at a football club, because that's what they've done in their own childhood. But try to explain to them how wonderfully Minecraft can teach you about the Boolean logic that powers computers, or how you can learn all these things and do creative stuff with computer science and coding, how it's one of the biggest intellectual achievements of humankind. You get a blank stare. So the parents in the room, next time you see your child in front of a computer, it's not a computer. It's a magic wand. It's a guitar. It's a treasure finder. It's anything the child imagines. Finally, what can Nordic countries bring into the mix? I come from Finland, the neighbor country to Sweden, and I think we are in a wonderful position for the next 100 years of technological advancement. Scandinavian countries, Northern European countries in general, they share a few things. First of all is our huge investment in education. Public education has been the tool that has powered Finland from a poor agricultural country into one of the best and happiest places on earth right now. And then we invest in equity. The Scandinavian societies believe that people fundamentally are equal. And I think these two things, education and equity, have given us a quite particular technological culture. When you look at Finland, for instance, an unproportionate amount of the software, the open source software that powers the world actually comes from our country. Companies like, well, not companies, but technologies like Linux, Git, SSH, IRC, the stuff that Nokia did, and so forth and so forth. And when you look at the Scandinavian region in general, it's really, really impressive to see the Ericsson, Rails, PHP, all of the stuff that Silicon Valley didn't invent. And it wasn't made to solve a private, small, small local problem, but it was built for everyone. And I think that is the legacy the social welfare systems give to us. We don't try to solve tiny hedonistic problems like our friends abroad. We try to build solutions that benefit everyone. So those three things, equity, education, and technology, combined with small countries that have a track record of being able to change quickly, I think they give us quite an interesting position to be working on these problems for the next 100 years. Finally, if we need to rename computer science to really bring out what the discipline is today, it's a problem-solving tool of self-expression. For the kids, I tell that coding is like Lego blocks, it's like crayons, it's like a guitar. I think another word that we need to reclaim is technology. Computers used to be humans. Being a computer was a profession in the Victorian era England, where people who were really good at calculating long series of numbers were called computers. And in some ways, I think the very last computers will be again human. And the word technology, I think, is really interesting because it actually comes from Greek. And it means tools to solve a problem. But not only tools, also skills and competencies and attitudes we humans bring into the problem-solving equation. For the Greek, agriculture was technology. Democracy was technology. I think it's fascinating when we think about being technologically literate. Today we think about being able to code or having social media skills, but yesterday's technology was the combustion engine. Before that, it was the bicycle. And we don't know what the future technology will look like, but we do know that we humans will be involved. So I'm going to leave you with a new definition of technology that was offered to me by a 9-year-old girl. I work a lot with schools and children, and I asked this group of 9-year-old children in the Helsinki English school to define to me what is technology, who uses technology, and what is it used for. And this 9-year-old girl, she solemnly writes, "Technology is electricity that loves." I'm just going to repeat it because it's the most poetic explanation of technology you will ever hear. So technology is electricity that loves. It is used to play. I use it to have a conversation with my mom. We use a WhatsApp application. And then finally, and maybe most importantly, she concludes, people uses technology. Thank you very much.